开始了是吧 ？OK。Ladies and gentlemen, respected academician Hui Junwang, President Li Xingtian, Dean Lin Wangyuan, and Vice Dean Cang Chunhuang, distinguished PMIP scientific committee members, dear local and remote participants, good afternoon in East Asia, good morning in Europe, and good night in America. I'm Jian Liu, professor at the School of Geography, Nanjing Normal University. On behalf of the local organizing committee, I warmly welcome you to join this conference. About a year ago, Dr. Pascal Bragla, on behalf of the PMIP Bureau, designated us to organize this conference. The COVID-19 pandemic made the organization extra challenging. We met with many difficulties. Here, on behalf of the local organizing committee, I want to acknowledge support from the sponsors. They are National Natural Science Foundation of China, Institute of Earth Environment, Chinese Academy of Science, Institute of Atmospheric Physics, Chinese Academy of Science, and the Pilot National Laboratory for Marine Science and Technology. Also, special thanks to Jing Wai, Peter Smith, for his great help on solving technical problems. Here, I would like to introduce the PMIP scientific committee members. They are Professor Pascal Braglat, Sandy Harrison, Betty Otto Blisler, Zhenyu Liu, Ayako Abeochi, and Johan Jung Klaus, Alan Haywood, Dan Nant, Zura Ivanovic, Chris Brearley, and Masa Kageyama. Thank you very much for your good ideas and suggestions for planning and organizing this conference. Here are the local committee members, including Professor Zhenyu Liu, Tianjun Zhou, Xiaodong Liu, Mi Yan, Ning Liang, Wei Yisun, Zheng Guoshi. Thank you so much for your hard working and everything you've done. Also, I would like to thank our university and school leaders and my graduate students for your help to take care of the logistics. Now, I have the great pleasure to invite academician Professor Hui Junwang to deliver his welcome speech. Professor Hui Junwang is the President of China Meteorological Society and the President of China National Committee of Climate Research. Most importantly, he is a pioneer in paleoclimate modeling in China. Let's welcome Professor Wang.
Thank you, Professor Liu Jian. Thank you for all the participants from China and abroad. Good morning, good afternoon, good evening, everybody. My name is Wang Huijun, professor in the Nanjing University of Information Science and Technology, also the chairman of the China Meteorological Society, and member of the WCRP Joint Steering Committee. It is my great honor to be invited to participate the opening part of the PMIP 2020 Nanjing Conference. organized by the Nanjing Normal University. Congratulations to PMIP 2020. PMIP started in the early 1990s as an international project for coordinating paleoclimate modeling activities designed to understand the mechanisms of climate change and evaluating climate models' ability to simulate paleoclimate that different from the present climate. It is a very important project in the world. So the PMIP organized various of model experiments for key past periods from being restricted to the last glacial maximum and the mid-Holocene. Now it is expanded to include the last millennium, the last interglacial, the Pliocene warm period, and last deglaciation, when the climate was at equilibrium, as well as simulations of the past climate changes. These experiments are designed to study the impact of the changes in both the boundary conditions and the external forcings, as well as the impact of feedbacks or new processes progressively added to the climate models. The availability of the results from many climate models allows an assessment of range of model responses and the robustness of the mechanisms leading to the simulated climate change in the past 30 years. PMIP have made great contributions to the understanding of the paleoclimate processes and mechanisms and the improvement of climate models around the world, including China, thus becoming a well-known, successful international project. My own research team also received great benefit from PMIP by using the output of different climate models and have published a large number of papers. The PMIP 2020 Nanjing Conference aims to review the progresses since the last PMIP meeting in Stockholm in the year 2017, to evaluate the models result of the new PMIP and CMIP simulations, to discuss the new approaches to quantitative climate reconstruction and comparisons with the model simulations, and to share the results on the paleoclimate studies, including climate transitions, abrupt changes, climate variability, and the linkage with the changes in climate mean state. The PMIP 2020 Nanjing Conference is a hybrid meeting with large numbers of online participants. I think this will make the PMIP 2020 a more attractive and more influential conference. Thus, I hope the conference a successful and productive one. Thank you very much for your attention. Thank you.
Thank you, Professor Wang. At the beginning, we would like to invite Professor Li Xingtian, the Vice President of Nanjing Normal University, to deliver a welcome speech. But he has another meeting, so he sent us a video to introduce our university and our school. Let's show the video.
Nanjing Normal University is a comprehensive university located in Nanjing, the ancient capital of 6 dynasties in Chinese history. It has 3 campuses, Xianling, Suiyuan, and Zijing campus, among which Suiyuan is renowned as the most beautiful campus of the Orient. The origin of Nanjing Normal University can be traced back to 1902 with the establishment of Sanjiang Normal College, which was one of the cradles of China's higher education. In the new millennium, Nanjing Normal University has experienced great development both in higher education and scientific research. The university consists of 28 schools which offer a diverse branch of learning such as physics, mathematics, earth sciences, and social sciences. Currently, there are more than 3,000 full-time members of faculty and staff, including 616 professors. Over 30,000 students are enrolled at the university. 40% of them are master and PhD students. It makes the university one of the largest in China. School of Geography is one of the most outstanding schools at the university. At present, the school has 160 members of faculty and staff with 57 full-time professors. Numbers of registered undergraduate students is close to 1,000 and graduate students are more than 500, including international students. In the past 20 years, the school have made a series of scientific achievements with international impact in quaternary climate change, archaeology, and GIS. In 2016, the discipline of geography has been ranked in the top 3 in China by the nationwide discipline evaluation by Ministry of Education of China. It is not only a recognition, but also provides a great opportunity for the School of Geography and Nanjing Normal University to get into the lists of nation-class and even world-class subjects and universities in the future. The school has just completed a new round of investment and update of laboratories with most advanced equipment to provide better working conditions for teaching and research. Such investment will be continued with priority from different sources. The university and the school are seeking and welcoming various kinds of communication and high-level collaboration with international communities, including but not limited to short or long-term staff recruitment and visiting, postdocs, student exchange, joint research programs. For excellent researchers and postdocs from worldwide, we offer internationally comparative salary packages along with extra benefits for accommodation and seat grant. We sincerely welcome you to the PMIP 2020 conference. May you all have a fruitful and joyful online meeting.
Because of limited time, I think I should stop here. Thank you for your attention. Now let's have a photo break. For the local participants, please go outside the meeting hall on the stairs. For the remote participant, please switch on your camera and let us take room photos. Thank you. Let's go back 5 minutes later.
Okay, so hi everybody.
We are a little bit behind the schedule. Pascal, can you hear me? Now, Dr. Pascal Bracklet will give a PMIP overview. Okay, let's play the video.
Okay, so hi everybody. So I have the pleasure to start with the PMIP overview today for PMIP coordination. And to start with, I would like to remind you that we are in the PMIP 4 phase and that PMIP is endorsed by both PAGES and WCRP. Okay, so today it's a very special day due to COVID. So we are both in presence and virtually in China. And I really would like to warmly thank our host in China because it has been a lot of work to prepare this PMIP 2020 meeting, and I hope it will be a success. So we have several ways of interactions with the online videos like now and discussions during these videos. We also propose Padlet for e-poster wall, and so that you can post your comments on the posters and also have discussions online to prepare the video discussions. So I hope you'll find your way in all this and you have the manual for it. So it's important in a meeting like this that we are all on the same page for PMIP. And just this slide to remind you that PMIP started in 1991. It's a very old MIP, just after the atmospheric one, AMIP. The objectives are still the same. We want to understand the mechanisms of past climate change and climate feedbacks. And we also want to be able to evaluate our climate model and the way they simulate a climate change. So what is PMIP today for all of us? I let you think about it. For me, it's a mixture of all the things I have written there, a coordinated suite of MIP experiments, a connection of several working groups, paleoclimate modeling and model data comparison network, and a service to the wide paleoclimate community and also other communities. I let you weight these different items and we can discuss that later during the week. Okay, so after the Stockholm meeting in 2017, we simplified a little bit PMIP organization, and we are now organized along 8 working groups, covering either different time periods or across the different periods like P2FR or PMIP data. And we have a specific group on PMIP infrastructure to gather all the information, the database, and the whole coordination of PMIP. An important part for us, and is part of a discussion of this meeting, is that PMIP is also associated with the CMIP and CMIP6 in particular. And I call this the PMIP-I for CMIP6. It has been drawn by Massa, and I really like this figure. It shows you where we are with our PMIP4. So we are here. I do not have the, okay. So with PMIP4, we are here where you have all the PMIP activities. It's broad activities, lots of subjects. And as part of that, we have isolated a few periods that can be connected with what people are doing in CMIP6 and what people are doing also for future climate. So we had the last millennium, the last interglacial, the mid-Pliocene, and we also have this particular period that are there from the beginning with the mid-Holocene and last glacial maximum. So these periods are intersect with the CMIP6 activities, so that with the same model, we can check what the model is doing for present day, for past paleoclimate, and for future climate. And we also can isolate different climate mechanisms across time and across different sensitivity experiments. We also, I would like to highlight that we also promise to have strong connections with CFMIP for climate sensitivity and clouds, ISMIP for the ice sheets, and VONMIP for volcanisms. Okay, so now lots of groups have done and run their PMIP4 CMIP6 simulations. I also put there this simulation, but several groups also run the PMIP4 simulation that are not here, but can also be posted on the SGF and are also discussed in several papers. So now we have 23 modeling groups contributed with different models. All these models, most of them have higher resolution compared to previous PMIP3 simulations and higher complexity too. I highlighted here the simulation that have been posted on ESGF and the one that are done and not yet posted. I really would like to encourage you to post your simulation on the database. And if you want also to have information, you have problems doing that, and so on, you can contact Jean-Yves Peter Schmidt. He has a poster on the conference, and he can open a page for discussing all the problems with you. I would like also to highlight that with the most complex model we have now, lots of groups have difficulties to run the LGM simulation, so we have to discuss that. And also that the last millennium is a little bit late because everything has been delayed in CMIP6 and this simulation takes lots of time. But things are progressing and we will see lots of results during this week. We also had this famous PMIP4 CMIP6 special issue jointly between Climate Overpass and GMD. On this issue, you can already have access to all the protocol papers, individual papers on the simulation and analysis done by different groups, and also community paper. And you will see some presentation from this community paper in next presentations. I put down the names of the editors because it's important that before you submit a paper to this special issue that you get in touch with them to check that your paper is a one that can be accepted in this issue and that your choice going to GMD or CP is the right one. I also mentioned that there is a specific special issue for PMIP and lots of you are involved in that. And of course, you're not obliged to submit in this special issue. And there are also lots of papers in other journals. It's important for us as part of PMIP coordination that we know all the papers that have been published using the PMIP resources, and that also you play the game to put the relevant paper in the IPCC list we open to help the lead author in the IPCC, and you have all this access on the PMIP website. So this meeting has been organized around key topics, and the reason for it is that we have limited time each day for the videos, only 3 hours, so we need to be condensed and focused. We identify the key topics from the abstract submission to see where the committee is going and where we could have very interesting discussions. And this is why we have this on monsoon, climate sensitivity, transient experiments, and ocean and internal variability. For all these topics, they are all key topics now discussed at the international levels, and it will be very interesting to see what PMIP is doing and what are the new results. I would like you to work during this week and help us to identify what is new in these results, which aspects are the most promising one, and we'll request further analysis or common analysis, and how we could launch something in between people. And is there a subject that would benefit from more interactions with the other MIPs? We also would like to pay particular attention on model data comparisons and the way to go forward, and also the topics are on results that are particularly relevant for future climate change and could be of interest for the IPCC assessment. I said at the beginning that PMIP is handled by PAGES and WCRP, and we have lots of connections between those two programs. And for PAGES, there's been lots and lots of work done in close collaboration with PAGES working groups, sorry if we highlight. And it brings new data synthesis, methodologies for model data comparison, data assimilation, and so on. We will discuss this week. We also have close linkages with WCRP, of course, through CMIP 6, but not only that, there are lots of people involved in WCRP panels, and for example, CLIVAR for the ocean and climate variability. And I would like to stress that PMIP is welcome in future WCRP activities. We have lighthouse activities under discussion. I put the names there. I don't want to go too far in this presentation, but I would like to engage you to look at the document, to tell what you think about these activities, and provide some topics that could be very relevant from PMIP in these activities, so that we can tell that to WCRP and make sure the Paleo is well present with as well as present day climate and future climate in these future common activities at the international level. Okay, so we'll ask you also to tell us if you think that PMIP4 is on track. We identify new scientific objectives, even though the old ones are still valid, in Namur in 2014, and they were discussed in Stockholm at the last PMIP meeting. I put the list here. So we need to know more about this ice sheet, dust, and modal biases, the role of this ice sheet and cryosphere in the climate system, new model data comparison with forward modeling, the transient simulation as a key new challenges and where we are now to that, and also methodologies to better analyze the interannual to millennium variability. I ask you also during this meeting, because it will be very intense, to focus really on what is going on and PMIP4. And this is because PMIP in 2001 will be 30-year-old. And we also plan to celebrate that with an event somewhere here in Saclay, where PMIP was launched. At that time, with a retrospective on what we achieved during all those years, and also brainstorming for new challenges in the future. So it will be somewhere at the end of next year or early in 2022. Of course, all this depends on the sanitary situation and all what we are living now. And we also will need you for all this. So my last word today is enjoy this meeting, and I hope we'll have lots of online discussion with you during all this week. Thank you.
Thank you, Pascal, for your interesting overview. Let's move on. Oh, Pascal, could you give a short talk about the latest news about the PMIP4 database?
Okay, so hello everybody. For the PMIP4 database, I think the best is that you look at Jean-Yves' poster. It's posted on day one. And then you get in touch with Jean-Yves so that he can answer all your questions and where we are with the database. I think it will be more efficient for that. Okay. So maybe we go with the other presentations, and then we have the suite of videos, and then the short time for discussion after that.
Okay. I would like to turn the chairmanship to you, Pascal. Could you chair the next talks?
Okay. Yeah.
Okay.
So the next talk is from Masaka Giyama. It's on so all the talks now are for these common papers that have been written and are on the PMIP special issue. And we think it's interesting that everybody knows about that, and we can discuss them. So the first one is from Masa. It's for last glacial maximum. So I'll let you launch the video for it. Thank you. So people, you can put question on the chat box, and then we wrap up at the end of the session. Yeah. So we do not see the video.
Hello everybody. This short presentation is about the last glacial maximum experiments from PMIP3 to PMIP4. The experimental design changed from PMIP3 to PMIP4 since we now allow the groups to choose between 3 ice sheet reconstructions and 3 dust datasets to estimate the uncertainties in climate simulations related to uncertainties in boundary conditions. As for PMIP3, it has proven difficult for the groups to run the LGM simulations. We have performed a short analysis from 9 PMIP3 simulations and 9 PMIP4 simulations. Some PMIP4 simulations are still running. First, let's investigate the results in terms of mean annual temperatures. The top left map shows the mean response of the PMIP4 models to the LGM boundary conditions, with the expected larger cooling over land than over oceans, and larger cooling at high latitudes than in the tropics. The bottom left map shows that the PMIP4 ensemble mean is generally less cold than the PMIP3 ensemble mean. However, the plots on the right-hand side show that one model, CESM 1.2, simulates a much larger cooling than the coldest PMIP3 model. the range of model results is larger in PMIP4 for the global average, as well as the averages over the southern extratropics and the tropics. The range is smaller for the northern extratropics. In terms of mean annual precipitation, the robust signal outside the stippled areas is a drying in the extratropics and in the ITCZ. Outside these areas, the modeled amplitude and sign of change are diverse, as shown by the zonal mean plots of the LGM-PI anomalies in precipitation, shown in the top right plots. The map at the bottom left shows that the ITCZ response is different in PMIP4 and PMIP3, and we are currently investigating whether this difference is related to changes in the representation of the PI state or in the response to the LGM boundary conditions. We have performed first data model comparisons at large scale, as shown on the left-hand side with two plots of LGM-PI differences over land on the y-axis and over the oceans on the x-axis. The averages for the reconstructions are shown by a black cross with gray shading. The top plot shows the comparisons to the datasets available in 2013 for the IPCC AR5. The bottom plot uses the latest data based on data assimilation. These latest results suggest that most models underestimate the LGM cooling in the tropics, both over land and over oceans. However, the land-sea contrast is compatible with the one computed from the available reconstructions. We have also performed comparisons at the regional scale, shown on the right-hand side. We can see that for many regions and climate variables, some models are within the range of the latest reconstructions, shown in red, while for others, like for Western Europe winter temperatures, the data model discrepancy remains. Thank you for your listening. We're expecting more results and many more analyses.
So thank you. So I propose we go to the next one now. Keep your question for the end. So the next one is from Chris Briley. It's about the mid-Holocene simulations. So the same, we use the video for Chris. It's also a way so that everybody has seen the same thing between the two sessions with the European time zone and the repeated one with the US one.
Hello, and welcome to this talk about the mid-Holocene experiment. I'm going to talk about this. My name's Chris Briley, and I'm at UCL. But this is not my work. This is the work of the whole community. So there are 36 different authors across 24 institutions on this work, and you can find this paper that was published last month in Climate of the Past. So the mid-Holocene, which is 6,000 years ago in PMIP speak, has been an experiment right at the inception of PMIP. And so this is the fourth time that we've done this experiment. And it's basically an orbital forcing run. The precise protocol can be seen in Betty's paper in the special issue of Climate of the Past. There's a slight change in the experiment since previous, in that as well as changing the orbital parameters, there's also a slight reduction in the greenhouse gases, most notably carbon dioxide by about 20 ppm. The other thing that isn't part of the protocol but has been included in the paper analysis for the first time is we've used BART's PaleoCalAdjust software to make some slight changes in the monthly timescales. In this work, there were 16 models included in the paper, of which 14 already have data on ESGF, and so this is analysis of that data. The the work done so far is really just a broad brush initial results from the ensemble. So we're starting mainly with temperatures and precipitations. So looking at the temperatures, as you get this strong seasonal signal that has more insolation in summer in the northern hemisphere, lo and behold, there's an increase in temperature in the northern hemisphere. So, over land specifically, because land has a greater seasonality than over the ocean, and there's a cooling in the winter associated with this. More work has been focused on precipitation, especially in the tropics, where where rainfall really defines the seasons. And you see some movement of the intertropical convergence zone with the changes in the orbital forcing, and so we're seeing that in this new batch of simulations. And if I just jump to the change from the previous generation, what you can see in this generation is there's some differences in the location and strength of, in effect, the ITCZ in both DJF and JJA. The most notable bit being over the West Africa, where you're seeing greater rainfall in summer. So there's an intensification of the West African monsoon in this new generation of PMIP simulations. And so this figure is just another way of showing that. And here you're looking at some large regions. So Northern Europe, Central Europe, the Mediterranean, the Sahara, Sahel region, and then East Asia, Eastern North America, and then a region of Central Asia that was defined by the Bartline, or by Bartline and Harrison, I think. Bartline et al. Certainly 2017. What you can see is over the Sahel region, there's a slight increase in the amount of rainfall between the different generations. The blue dots here are the PMIP3, and then all of the coloured ones are the PMIP4. However, compared to this, the pollen reconstructions, we're still a long way off the amount of increased rainfall that would be required. This is an area average versus some site lay data, so it's not necessarily ideal, but it's a fairly standard procedure, and this is the plot that's included in the paper. So I'll just spend a few seconds wrapping up. I've highlighted some of the key results. There was also work on the AMOC, on the sea ice extent, and on the monsoons. The monsoons is going to be discussed by Annie Zhao, my PhD student. The AMOC's being discussed in a different paper. I don't know if anybody's presenting stuff on the sea ice that's been included in this paper, PMIP, but it's there in the paper if you want to see it. And so I've just put a summary of the published paper, or the published research over here. I very much see this as the first of many papers coming out of this ensemble, and so just on the right hand side here, I'm suggesting some further research that we could do looking at these simulations.
So, thank you. So we move to the next one. So the next one is by Alan Haywood. So we are moving in time, and we go to the Pliocene now with Alan's presentation. So you can include some question in the chat box if you want, so that we know for the end of the session where we go with the questions.
Hello, my name is Alan Haywood, and on behalf of the whole community, I'd like to present a summary of the large-scale features of climate and climate sensitivity from the second phase of the Pliocene model intercomparison project. So by a brief way of introduction to PMIP2, the project started in approximately 2015. Compared to PMIP1, we have focused a narrower interval of time within the mid-Pliocene warm period, the KM5C interglacial. The CO2 parameters for the modeling were very similar to PMIP1, as was the orbital configuration. We are using an updated data set of geological boundary conditions provided by the US Geological Survey's PRISM project. And I'm showing you on the right of this screen the land-sea mask, ice sheet distribution, and the topography which we've used in the models. And in PMIP2, one of the key changes have been more significant variations in the land-sea mask compared to PMIP1. So here we have, and you can see I've highlighted the closure of the Bering Strait, the closure of the Canadian archipelago, but there are also other significant changes in Southeast Asia in terms of the Sahul and Sunda Shelf and the Indonesian through flow. So in PMIP2, we have 16 plus models. 16 models are included in the data I'm going to show you here today. An additional model has become available, HADGEM3, since, so we have a total of 17. And the sea surface temperature data, which I'm going to show you for the DMC, the data model comparison, is that of Foley and Dalset, which is specifically for the KM5C interglacial. But there are also alternative data sets available through the Pliovar project and Erin McClymont's paper this year in Climate of the Past. So here are some results which show the multi-model mean surface air temperature anomaly and also the precipitation anomaly. And I've superimposed on this a data model comparison for you. So the global model, the global mean, multi-model mean surface air temperature increases by 3.2 degrees Celsius compared to 2.7 in PMIP1. The global model mean precipitation increases by 0.9 millimeters per day. In 17 of the 37 sites we've included for the data model comparison, the multi-model mean sea surface temperature is within 1 degree of the data. And overall, it appears to be a situation that PMIP2 model data agreement has improved relative to PMIP1. And that the multi-model mean sea surface temperature has a better data model agreement than any individual model. So the take-home message from this slide is that PMIP2 shows a larger global climate signal than PMIP1, which appears to be in better agreement with the paleo data. So let's look at some of the results for temperature and precipitation from the individual models within the ensemble. So the PMIP2 models have a global mean surface air temperature anomaly between 1.7 and 5.2 degrees Celsius as compared to 1.8 and 3.6 in PMIP1. The global mean precipitation anomalies are 0.07 to 0.37, whereas in PMIP1 they were 0.09 to 0.18. The models that contributed to both PMIP2 and PMIP1 are marked in the red squares. And so you can see that many of the new models which have been introduced into PMIP2 are sensitive, more sensitive than the models we used in PMIP1 and PMIP2, and show a larger climate signal. So the conclusion to this slide is that the increased global climate signal in PMIP2 is largely due to the addition of more sensitive models in the ensemble. And now let's have a look at the polar amplification and land-sea temperature contrast. So in PMIP2, the multi-model mean, the region of poleward of 60 degrees warms 2.3 times as much as the global mean. In the multi-model mean, the polar amplification is the same in both hemispheres, at least in the way that we calculated it here. The multi-model mean polar amplification is the same in PMIP2 as it was in PMIP1, but individual models do show a large spread. The land warms 1.5 times as much as the ocean, and that is a similar result in PMIP2 to what we found in PMIP1. And let's conclude by looking at equilibrium climate sensitivity. I don't have the detail or the time, I don't have the time to go into the method in full detail, but it's outlined in the accompanying paper, and it follows broadly a methodology that was used by Hargreaves and Annan in 2016 with some specific differences. So PMIP2 equilibrium climate sensitivity was estimated from data at individual sites and using the modeling results. The equilibrium climate sensitivity estimates are independent and each include a number of uncertainties due to both the data and the modeling. And in conclusion, the PMIP2 equilibrium climate sensitivity estimates range from 2.6 to 4.8, whereas in PMIP1 they were 1.9 to 3.7, and the IPCC, the previously published IPCC estimates are 1.5 to 4.8. So equilibrium climate sensitivity is estimated independently at each of the 13 sites, and all estimated ECSs are in the range between 2.6 and 4.8, which appear to be broadly consistent and supportive of previously published IPCC estimates for equilibrium climate sensitivity. Thank you very much for your attention.
Thank you. So we will move now to Dan Lutz, and it's for DeepMIP simulations.
Hi everyone, I'm Dan Lunt and I'm going to introduce DeepMIP. And DeepMIP is really dedicated to model data comparisons and process understanding for deep time climates, which we can sort of define as anything prior to the Pliocene. And the motivation for this really is from the fact that some of these deep time climates have exceptionally high CO2 and temperatures probably not dissimilar from those that we might expect from the end of this century and beyond. In particular, we've got a focus on, at the moment, on the ECO, Earliocene climatic optimum about 50 million years ago. So our experimental design includes changes in paleogeography, prescribed changes in vegetation, and multiple CO2 concentrations. In terms of proxies available, we have this Hollis et al. Paper, which formally defines the interval that we're interested in, as well as discussing strengths and weaknesses of various different proxies and presenting versions 0.1 of the ECO marine and terrestrial temperature database that we're going to use to evaluate the models. So far, we've published this Inglis et al. Paper, which provides just purely from the data an estimate of global mean temperature and climate sensitivity. For the ECO, we have 8 modeling groups that have carried out the DeepMIP simulations within the DeepMIP database, and a paper submitted under review that describes the large-scale features and model data comparison for these simulations. In terms of what's in the pipeline, we have many groups, in fact 19 papers currently planned, analysing various different aspects of the ensemble, from ocean circulation to precipitation, Antarctic climate, westerlies, clouds, monsoons, sea ice, and many others. Also, we've sort of made a strong contribution to IPCC across various different chapters. What I'd like to do is just introduce very quickly the results of our overview paper in review. Here are the people, the most important people who've done all the work, those who've carried out the model simulations. These are the 3 questions that we tried to address in the paper. What are the large-scale features? What are the causes of the differences between the models? And how well do the models fit the data? Like I said, these various different models have this consistent boundary conditions, but different initial conditions and multiple CO2 concentrations. Here are the model simulations, the models that took part. And here are the results in terms of global mean temperature as a function of CO2. First thing you'll notice, the colored dots are the DeepMIP simulations, the gray dots are previous simulations, and the DeepMIP simulations, especially accepting the Russian model here, are much more consistent, perhaps because of the standard experimental design. And the models have higher climate sensitivity on average than previous versions. Some of the models show a quite non-linear increase in their climate sensitivity. And when we look at polar amplification, we see 2 different groupings, really, of those models with high polar amplification, here as a function of global mean surface temperature, and those with less polar amplification. When we look at the spatial features of the response, we see the things you'd expect to see, like land-sea contrast, polar amplification, the presence of the different paleogeography, which you can particularly highlight if you just look at those models that carried out simulations at 1 times CO2 compared with pre-industrial. And you can see very clearly the impact of the different orography, the removal of the Antarctic ice sheet, different continental positions On average, these non-CO2 boundary conditions contribute anything between about 3 and 5 degrees C of warmth. When you look at the total amount of warmth across those simulations that allowed us to do this analysis, we get 10 degrees C of warming at 3 times CO2. And it turns out that the main contributor to that is actually is the CO2, the pure emissivity change due to the CO2 and the associated water vapor feedbacks. Whereas when we look at the polar amplification change, that is primarily driven by the non-CO2 forcings, the change in height of Antarctica and the albedo change associated with that. We were able to do this analysis using a simple energy balance, a 1D energy balance approach. When we look at the model data comparison, we see that the simulations at 4 times, 6 times, 9 times are all consistent with the CO2 proxies. Here are the temperature and CO2 constraints in the grey box. And the CSM, GFDL, and NORI-SM DeepMIP simulations, as well as the older CCSM3 simulations, are all consistent with the proxy constraints we have on CO2, global mean temperature, and meridional temperature gradient. We also did a regional model data comparison, which you can read about in the paper, and I'll leave you with the conclusions from that study. And I'm very excited about all the work that's coming out soon. Thank you.
Okay, so we moved to the next one by doing it and answer across different time periods. You have a chance to look at the videos again on the website. Okay, so next one.
Hello, and thanks for giving me the opportunity to present this work. This is a study using the available simulations from the new PMIP4 models as well as the PMIP3 ensemble, focused on past and future simulations of ENSO. And you can see the list of contributors, including those that were involved in writing the paper, and also those that contributed the model runs. And this work was inspired by the 2019 PMIP Past to Future workshop that was held in London. So this study is just a first look at ENSO in these simulations. Obviously, there will be a lot more studies that will look at different aspects of ENSO, but we wanted to compare the last glacial maximum, last interglacial, and mid-Holocene past climate simulations with the future idealized 1% per year CO2 and abrupt 4 times CO2 simulations. And the questions that we wanted to address are, firstly, how does the mean state change? And we compare in each case with the pre-industrial climate. And then how do the spatial pattern and amplitude of ENSO change, again, compared with pre-industrial? And finally, we looked at the temperature and rainfall teleconnections as well, although I won't really have time to talk about those here. So I'll just show you firstly the mean state change. This is the seasonal change in DJF and JJA, calendar adjusted for the paleo simulations, relative to the pre-industrial. And we have the mid-Holocene, LGM, last interglacial, 1% CO2 and abrupt 4 times CO2 runs. And you can see a number of interesting features, including the relative cooling in the equatorial Pacific in both the mid-Holocene and in particular in the last interglacial in DJF, which is obviously in response to the seasonal insolation changes. And the enhanced warming, which has been identified in many other studies, in the future warming scenarios in the equatorial Pacific. So all of these mean state changes may, of course, have an impact on ENSO. We then looked at how ENSO itself changes. And we have the change for each of the experiments relative to pre-industrial for each individual model. And just to summarize the main interesting results, we have a consistent reduction in amplitude of ENSO variability in both the mid-Holocene and the last interglacial, with a larger reduction in the last interglacial. Changes in the other simulations are less clear. And you can see that the changes in both CMIP5 and CMIP6 models are generally in agreement. We then looked at the spatial pattern of SST variability using a composite El Nino minus La Nina, and we can see that there are some changes in all of the experiments relative to the pre-industrial. So we have relative cooling in the center of the Eastern Pacific in the mid-Holocene and last interglacial, consistent with a weakening of ENSO, and we have a reduction in variability over towards the Western Pacific in the LGM case, and an increase in the future idealized simulations in terms of stronger warm anomalies. Finally, we looked at whether there were any relationships between ENSO changes and aspects of the mean state. And this is just showing on, firstly, the ENSO amplitude change versus annual cycle for all 5 experiments relative to the pre-industrial. And there is a weak positive correlation between the ENSO amplitude and annual cycle change, but it's not a very strong relationship. We also found, consistent with previous studies, that the El Nino rainfall composite in the Nino 3 region is negatively correlated with the Eastern Pacific meridional SST gradient. It's a strong negative correlation. So that's all I have to present today, and thank you very much for listening. Please check out our paper if you would like further details.
Okay, good. So the last speaker is not online yet, but we have the video, so it will be Beth Autopista, and it's about the last interglacial climate and the new simulations.
In the next 5 minutes, I would like to quickly show you just a few results from the CMIP6, PMIP4 last interglacial simulations. Contributions by many, but I especially want to give specific call out to Esther, Annie, and Chris, who were instrumental in the analysis. The last interglacial has drawn the attention of the scientific community because geologic records indicate a warm Arctic and higher sea level. 17 models have completed the Tier 1 simulations for the 127,000 years ago. And notable and interesting is the spread of the equilibrium climate sensitivity in these models, a metric used by IPCC from its start. The primary forcing change for modern are the large insolation anomalies from modern associated with a very large eccentricity and perihelion near the northern hemisphere summer solstice. As you can see from these plots, that at high latitudes during the northern hemisphere summer, there's more than 60 watts per meter squared more solar insolation, or more than 15% increase as compared to the pre-industrial. And these positive anomalies extend down to 60 south and extend from March to September, with the magnitude of the anomalies much greater than 6,000 years ago, and a different seasonal and latitudinal structure. For these simulations, the greenhouse gases are similar to pre-industrial. The continents and oceans are at modern. And for the protocols, we asked the modelers to keep the ice sheets at their modern extent and elevation. And for those models that didn't have interactive vegetation, use their pre-industrial vegetation distribution. The climate system responds to these insolation anomalies by having annual warming here, as shown here in one of the models, CESM2, at the polar latitudes of both hemispheres. This is robust across the models, with greater than 70% of the models agreeing on the sign of the change, but considerable spread in the magnitude. We have cooling over North Africa and Southern Asia, with the greater area extent and total rainfall than pre-industrial or the mid-Holocene simulations. The color-filled circles show you the data that we compared the simulations to. And in particular, notice that we have significant gaps over the continents, but also large expanses of the oceans. The models simulate a 50% reduction in the minimum sea ice in the Arctic, with a multi-model mean here of 3.1 million kilometers squared in sea ice area, but a large range, 7.5 million kilometers in the INM model, and basically an ice-free summer in the HAD-GEM model. There's also a clear relationship between the minimum Arctic sea ice in August, September, and both the annual temperatures and the June, July, August temperatures. So the warming in those 2 times, with the correlations being significant at the 0.05 significance level. These results are relevant to future projections also. There's a clear relationship here shown in the left figure between the equilibrium climate sensitivity and the minimum Arctic summer sea ice area of the models with higher ECS showing more sea ice during the summers in the last interglacial, and those with higher showing much less Arctic sea ice. There's also shown here from a figure from Masakagiyama et al. A relationship between the last interglacial sea ice area in the summer months and that in these idealized 1% CO2 simulations at time of doubling. So what does the last interglacial warmth imply for the Greenland ice sheet? As I said, the Greenland ice sheet is fixed in our simulations, but what if we did couple them? Here's the surface mass balance for 3 time periods in the CESM diagnostic for the last interglacial, the mid-Holocene, and the PI control. And what these simulations suggest is this blue area here is where the model suggests there'd be ablation forced by the warmer climate of the last interglacial over Greenland, that there'd be potential retreat of the Western Greenland ice sheet. So as we look forward to PMIP 5, some new coupled ice sheet simulations for our paleo time periods will be of interest to CMIP 7 and IMSMIP 7. So thank you for your attention today. I've listed here a few papers that you might want to refer to for the synthesis, but also the individual models. And also there's a poster and a lightning talk on Tuesday in the monsoon session by Annie Zhao, where she'll present some of the results on the monsoon that I didn't have time to speak about today. Thank you.
Okay, so I would like to thank all the speakers for this introductive session on these common papers. I think we need to take some time for just a few questions or comment here. So if you want to take the floor, just put an exclamation mark in the chat box or a comment in the box, and maybe there is something from the room in China. So I see one comment already from in the chat box to Josephine. It's Sandy. Would you like to raise your question? You need to unmute the people if we want to go on. Please, could you unmute and we wait a little bit for the next talk.
Hi everyone, I'm Dan Lunt and I'm going to introduce this session on PMIP and the IPCC. So I'll start off with, looking back and giving a brief summary of the 5th assessment report, AR5, before going on to talk about the structure and timeline of AR6, to talk about our group of paleoclimate scientists that we have working together on the IPCC, the so-called Paleoclimate BOG, or breakout group. Then I'll show some key figures from that will originate really from data from PMIP models that we're hoping to include in the 6th assessment report. And then I'll finish off with some personal reflections on the process so far. But then we'll get on to really what is the most important part of this session, which is an open discussion and Q&A. And at the top here, you can see the various people who will be attending or be on the panel for that part of the discussion across the 2 sessions that we have at the 2 time zones. So just to remind ourselves about AR5, well, of course, we had this paleoclimate chapter information from Paleoclimate Archives. And in there were lots of very nice figures that showed PMIP work. So for example, this figure on polar amplification that showed the LGM, mid-Pliocene warm period, and the early Eocene climatic optimum, and the model data comparison of in the SST and in the marine and terrestrial realms. And then we had this nice model data comparison of the last interglacial. We had a model data comparison of the last millennium. And then looking at the temperature response and precipitation response to the 8.2 kiloyear event, and a panel on model data comparison for the mid-Holocene temperature of the coldest and warmest month. Also, outside of this single chapter on paleoclimate, we had chapter 9 on evaluation of climate models, and there was a section of that on the PMIP simulation. So we had a model data comparison for the temperature at the LGM and the precipitation at the mid-Holocene, as well as a figure showing land-sea contrast, model data comparison, and precipitation in the mid-Holocene. And also this sort of metric-based so-called carpet or Geckler plot, looking at lots of different metrics for the last glacial maximum and mid-Holocene across the PMIP ensemble. So that's where we were in those two, the information from PMIP in AR5. It's, it's interesting to think how much of that ended up in the summary for policymakers, and actually there wasn't a huge amount, despite lots of really great work underlying in the chapters. There wasn't a huge amount in the summary for policymakers. And in fact, there's, very little really about PMIP models. Even just on the paleo side, there was this short bullet point here looking at last interglacial sea level rise that was partly, at least, informed by some model simulations, but not really very much that got into the summary for policymakers in the end. So what about AR6? Well, this is the structure of the new report. You can see there's this, overarching chapter 1 that gives the framing, context, and methods, and then we go through observations, really, and then projections, and then 4 chapters that look at really sort of process-based chapters and mechanisms, and then gradually sort of going more and more regional until we get into climate change information for regional impact and risk assessment. Now, this is from the scoping document, and also in the original scoping document for IPCC, there was this statement here that said each chapter is expected to build on all available lines of evidence, including, and there was a list of things, one of which was paleoclimatic evidence. So as we all know, there was no paleoclimate chapter in AR6, but the idea was that it was integrated throughout and permeated throughout the whole report. Where are we now in terms of this process? Well, we're actually getting towards, thank goodness, the final stages. And work is currently undergoing on what we call the final government draft. We've done the ZOD, which was the zero-order draft, the FOD, the first-order draft, the SOD, the second-order draft, and now we're onto the FGD, final government draft. And, just to indicate a few key things in the final throes of writing this assessment report, we're currently at the stage of revising chapters and responding to comments on the second-order draft. And at the point where we're going to finalize or get a additional draft, next draft of our executive summaries. And it turns out, I didn't really realize this when I started the process, the executive summaries are really important because they summarize in just a couple of pages the entire chapter. But it turns out that really to be included in the summary for policymakers or the technical summary, you can only really include the work that's included in those executive summaries. So getting paleoclimate information into those executive summaries is quite crucial. So that's something that we're working on at the moment. In addition to that, there's an opportunity to highlight papers that have been published since the second order draft or that have been brought to our attention. So that's, from a PMIP perspective, if you have papers coming out, then please do continue to send them to us if you think that they have relevance for the various different chapters. We'll then have once we've completed this final government draft or the draft of the final government draft, we will then have an internal review of that. Another useful date for you all is that the revised deadline for the final acceptance cutoff date for papers to be included in the report is the 31st of January. Now, in practice, it's very difficult. If we don't know about papers already, it's very difficult. Obviously, it would be very, very difficult to include them at this very late stage. But if you do have papers that you think will make this deadline, again, please do send them to us. And then finally, the very end of the process for most of us will be sometime towards the end of March, when we will submit the final government draft and the technical summary. So that's where we are. There's still a bit of work to do, and we're talking, in fact, the entire process, including the summary for policymakers, won't really be over probably until sometime in July. So given that we don't have this paleoclimate chapter in AR6, how have we been organising ourselves? Well, really, we've self-organised. The paleoclimate community has come together. The lead authors, who sort of self-identify as paleoscientists, if you like, have come together in what we call a paleoclimate bog. There are various different bogs throughout the IPCC, these breakout groups, and one of them is a paleoclimate one. And we have, this isn't everyone in the paleoclimate bog, but these are some people you might recognize here from the PMIP community. And really, we've been informally trying to self-organize ourselves, having meetings at the various different lead author meetings. And we've brought together a number of key questions that we think that not just paleo modeling, but paleoclimate in general can contribute to the various different chapters and to the IPCC. So, for example, for using the paleoclimate to explain how unusual is recent change, how unusual is anthropogenic change in the context of longer timescales, and what are the spatial patterns of change in terms of land sea contrast, polar amplification, zonal gradients, and then, of course, evaluating models. How good are the models? Can we, when we force them with an out of sample forcing, how do they respond? How well do they respond? And then also quantifying natural variability, so that we have again, I guess it sort of relates to the first one, how unusual are past changes, but also giving us an envelope of natural variability over a longer time scale than that which we can get from just the historical record, observational record. And then also thinking about very long time scales in the future and long-term equilibrium change. Again, that's something that paleo can tell us about. So these, we think, are the key aspects that we really want to draw out in the various different chapters. So what is there? It's PMIP has been, has contributed a lot to this process. And what I thought would be nice to show is just some of the figures that are emerging. None of these are finalized as of yet, but some of the figures that are emerging coming out of PMIP modeling work that we think is going to contribute to IPCC. And so I'm not going to highlight all of them, but just some of them. So first of all, in chapter 2, which is this observational chapter on the changing state of the climate system, there is what we call a cross-chapter box, which links together work from various different chapters, and that's focusing on the Pliocene time period. And as part of that cross-chapter box, there is this figure here, which shows the PMIP models in the background with the Pliovar SSTs and some of Ulrich Salzmann's terrestrial temperatures overlaid on top. So a form of model data comparison plot looking at how well our models can simulate the Pliocene warm period. We've then got there are some figures in chapter 3, which is, it's called the human influence on the climate system. But really, there are two components to this chapter. One is looking at detection and attribution, but just prior to that, they evaluate the models that are used for detection and attribution first to as a sort of proof of concept, if you like, or saying that they're fit for purpose. And as part of that, we have this figure Andrew Shaw has put together of the last millennium and the observations in the grey bars and the PMIP models in the coloured lines. I believe that the green line is the only CMIP6 model that we currently have. Andrew will correct me if that's wrong, but the other ones are CMIP5 with two different volcanic forcings as shown here. So again, this is a form of model data comparison for the last millennium component of PMIP. We then have some other figures in chapter 3. So one again on land-sea contrast, comparing sort of PMIP3, I guess, really, with PMIP4 down here with new data and new models. Looking at the terrestrial, the marine temperature on the x-axis and terrestrial temperature change on the y-axis at the LGM. And then we have this sort of the new latest version of the metric style plot is this one. Again, we've got some PMIP3 models compared with we've got the mid-Holocene at the top compared to the LGM underneath, and we've got observations, which are the red bars, and you've got PMIP3 versus PMIP4 models here. So again, looking at various different variables and various different regions to give an overview of the validity of some of these models that we're showing here. Then we have another figure that focuses really on the mid-Holocene, looks at more regions and looks at the precipitation. Again, a comparison of the PMIP4 models with the PMIP3 models with observations in these various different regions. In chapter 7, energy budget, feedbacks and climate sensitivity. Part of this chapter is looking at polar amplification, and this is a figure here showing that for three climates that are driven, really their difference to modern is driven by CO2, so the eco, the Pliocene and the LGM, and looking as well as at the spatial, looking at the zonal mean in the models and in the proxies. So again, form of model evaluation. Also in this chapter, we've got a figure looking at the non-linearity of climate sensitivity. And of course, many of the models that contribute to this were originally carried out in a paleoclimate context, because they're the sort of only ones that are going to go up to such high CO2s or really explore such a broad range of global mean temperature. So we've got some models and paleo models and proxies in this figure, looking at how climate sensitivity varies as a function of background state. And then in chapter 8, which is focusing on the hydrological cycle, we've got a comparison for the Younger Dryas of PMIP models in the background and proxies in the coloured plots, coloured circles, and then comparing this with model simulations of an idealized AMOC collapse. So in some ways, using the proxies here to evaluate these sort of future idealized scenarios, really, indirectly through evaluating the Younger Dryas. And then chapter 9 is the oceans, cryosphere and sea level. And in here, there is some simulations, some ice sheet simulations that themselves have been, I believe, driven to a certain extent by PMIP model simulations of the LGM last interglacial and mid-Pliocene warm period. So that is, in terms of the main figures, I would argue those are the main contributions from PMIP into AR6 currently as it stands. And I thought I would just finish off really before we get onto the discussion, and other panel members will have their opportunity to do this as well. But I just thought I'd share with you some sort of personal reflections on the process so far. So this is purely, I'm not speaking on behalf of the other panel members in any way, or the Paleoclimate Bog now. I'm speaking sort of from myself. So first of all, on this question of having one paleo chapter compared to having it integrated throughout the whole report, I was a little bit skeptical at first, I guess, when the process first started. But the more I've done, the more I'm convinced that actually this has real potential for better highlighting the policy relevance of the PMIP work and paleoclimate work in general, and raising that profile in the future climate community, being integrated throughout other chapters. We have much more communication. We're working much more closely with the future climate community, and actually I think they are learning a lot more about paleoclimate through working directly with us, integrated throughout all the chapters. So I think there is certainly real potential there. However, it has been very, quite difficult at times to coordinate ourselves in the absence of a sort of a very formal IPCC chapter structure. One of the reasons for this is that, almost everything that goes on in IPCC and the meetings and the emails and everything is built around chapters. The whole hierarchy of IPCC is very much chapter based. And so trying to coordinate something that is across all the chapters is very difficult. And ultimately the decisions are made by the lead authors on those chapters, not by this sort of paleoclimate working group. And it can be quite difficult to, it can be quite difficult at times to make sure that everything is coordinated and that the paleoclimate is having the influence and the profile that it should do, given its importance. In this case, in particular, it's been a bit hard with chapter 3, which is the model evaluation chapter, because there are no lead authors on that chapter from the paleoclimate community. And as such, there is no paleo representation in any of their meetings, in any of those sort of formal structures. And so including those PMIP simulations and PMIP, the model evaluation of PMIP simulations has actually been quite challenging. And sort of on that note related to that, this is, we're getting into a bit of detail here, but one thing that I think would be incredibly useful in the future going forward, not only for IPCC, but for PMIP as a whole, is to have some sort of standard plots that we produce as model simulations come out. And I know some people have been doing some work towards doing this, but I do think it would be extremely useful to integrate PMIP into the ESM Val tool, because that is being used extensively now in IPCC, and it would in the future, not only for IPCC, like I say, but just for generating plots for papers associated with PMIP. It would be extremely useful if these were integrated into this tool. It's still to be seen whether this new structure of having the paleoclimate federated throughout the report will result in more or less paleo content ultimately in the technical summary or SPM, because those haven't been finalized yet, but we'll see in a few months' time. And it has been hard work. If anyone who's thinking of being involved in the IPCC in the future, it is extremely hard work at times. Deadlines come around very quickly, and they're in really intense periods of working. But also, I've found it extremely rewarding and super interesting and fascinating. And in particular, I've valued the opportunity to work much more closely with the future climate community and to talk to them about the paleo work that we do. And also, just finally to say, I hope that basically we have represented you, the PMIP community, well, and paleoclimate in more general. And we would love to hear your thoughts, and I hope this has kicked off some interesting discussion and Q&A for the panel. Okay, thank you.
Okay, so thank you, Dan, for this introduction. Before I let the floor to Dan to chair the session, I would like to introduce this session just a little bit, because it went very fast for the video. We decided to have this kind of session as an echo to the one we had in Stockholm. In Stockholm, it was time where the outlines of the chapters were there, and we were wondering where the paleo could go, if we would have new results in time that are interesting for an IPCC assessment. And finally, it proved to be the case, even if it's a rush. We decided to have that, and Dan has shown quite a lot of figures that are relevant and from the paleoclimate community. it's clear that it also raised some question because as it is now, these results belong to the community, so we can discuss them. But what we cannot do is really to exactly tell what is in the IPCC report now, because this is still not a public report. It's a report that is under review, that is under revision. So things might change in the text and the way it is formulated. And there are still figures that might change for the future. So we ask all of you to keep all this discussion and the slides for the public, for the PMIP discussions, excuse me, and not distribute all this outside, because it should not go into discussion files that we do not know. And it's the IPCC, as long as it's not released, should remain within the communities and not outside. So we have several people now for the panel discussion. So for the discussion, normally you're all unmuted. We also have people in the room in China. So what the rules will be, if you want to take the floor, please put an exclamation mark in the chat panel or a question there. And then we'll see all this and give the floor to people. And we've done today, we have also Massa, Chris, and Andrew, who are part of the process, either as author or mainly contributing authors, and most of them drew the figures you've seen there. So Dan, I let you the floor.
Okay.
Yes, so sorry, I just forgot to tell people that when you do not speak, please mute your microphone and unmute when you speak, because there might be echoes otherwise.
Okay, thank you, Pascal. I must admit, you caught me a little bit on the hoof because I was not expecting to be here. I've just, ironically, I've just had an IPCC chapter meeting. It just finished early, so I thought I'd pop my head in to see how things were going here. But I've just found out that I'm chairing the session. Okay, so I believe, so just to check, I believe that we have Massa, Chris, and Andrew here as panel members who can answer questions that people might have in terms of their experience. I just thought we could start off by really calling on them to say a few words. So I just wondered if, well, let's choose Chris first, if you could perhaps give us a couple of minutes just on your experience of the process of being involved with IPCC.
Okay, I'd be happy to. I feel that I've actually been lucky watching and talking to you, Dan. So I'm a contributing author to the report. And so what that has ended up meaning, or at least it started off by being asked if I could provide a figure from a paper I'd passed on one of the mid-Holocene paper, and then I was asked by Marcela Barrero if I could provide an up-to-date version of a figure, which I did, not really expecting anything, and then discovered later that I had been elevated to contributing author status, which has been quite pleasant. I have joined in questions, but I feel I've mainly been responsive, not proactive in this IPCC round, and I haven't needed to go to any of the lead author meetings. I'm involved in chapter 3 and getting some figures related to that. The other side of things I have been a bit more involved with, which is the PMIP, directly the PMIP stuff, in that my involvement with the mid-Holocene paper really, I suppose, arose because there was a fear that with the simulations taking so long, that there wouldn't be papers that could be referenced by the IPCC. And so I started to be proactive, trying to make sure that there were outputs for PMIP. And I guess I focused myself on model analysis and building scripts to get model analysis done as soon as data arrived, and trying to be proactive on that front within the community to hopefully try and feed in. And obviously there has been some feeding into the IPCC. So I'll leave it there if that's all right.
Great, thanks very much, Chris. So I think we also, that was interesting to hear that. Thank you. We also have Massa here, I believe. So I wonder if Massa could, before we go on to answer some of the questions, let's hear from these three people on the panel. So Massa, if you could say a few words if you're around, please.
Yeah. Hello, everybody. Can you hear me?
Yes,
okay.
I can hear you.
So I had a reflection on this chapter 3, because you said that there was no paleo lead author in that one, but that's probably the chapter in which we have most or a lot of figures in the end from PMIP. So it shows that the process actually works, and we were asked, as Chris said, to provide some figures. Maybe the drawback on this was that it was sometimes difficult to remain ourselves, in the sense that sometimes we were asked things that we couldn't do, or I didn't believe, for example, in providing global mean surface temperatures for all the periods as being the most relevant for paleoclimates. And in the end, we have this regional comparison, which I think serves better gives more potential to what we do. But it was interesting all the same. And we have to, I think there was this thought about making our scripts and analysis available through, I mean, you said ESM Val tool, but it could be any tool, I think. This actually means that we have to put the data on ESGF, which was highlighted before by Pascal, but also to have the reconstruction and data for in a format that is useful for, or that is easy to manipulate for modelers or modelers outside our community, I would say. So that's something I think we should think about. You're right that we should do something about this, and we are progressing at least. So yes, a lot of things. Sometimes it would have been good to have more discussion all together. We had them very late, I think, and pushing for some results to be published in time can be useful, but sometimes it can also lead to things that are done too fast. So we have to be careful about this, and I think there's quite a lot already in the report, and maybe we shouldn't push too much. It would make also your life easier probably in January. Okay. I think that's all.
Okay, thanks very much, Massa. That's very interesting to hear as well. And so finally, I'll just pass over to the final panel member, who's Andrew Shora. So if Andrew's here, if he would like to reflect on his experience.
Hi everyone. I hope you can all hear me okay. Yes? Good. So yeah, so a bit like Chris, I suppose my involvement has been as a contributing author. So I haven't found this probably anywhere near as stressful as some people. My paleo contribution has been a bit tangential. I initially was a contributing author on chapter 3 for precipitation figure I'd put to get so I published a paper looking at wet and dry regions precipitation over the satellite era, and I was asked to contribute that figure to the to chapter 3. But so that was nothing obviously to do with paleo. But in the same time, I put in a comment on, as I think other people did, on the latest review round, suggesting that maybe it would be nice to get a last millennium figure into chapter 3, and then found myself rapidly volunteered to produce the figure, which was fine. So essentially, I've been equally. I'm also responsible for a block of text for chapter 3 for the last millennium. So that, yes, I think this has been, I found that I've mainly been told what to do rather than, I mean, I'm not in charge of any overall, organization of the chapter. So yeah, so it's not been too bad. Obviously with the last millennium with CMIP 6, there's a slight issue with the lack of simulations. And I think maybe there's been a bit of skepticism there because people want the newest simulations. And obviously we've only got 1 or 2 at the moment. But compared to the previous IPCC report, there's been an awful lot of progress made on the reconstructions. And there's also been a lot more CMIP 5 level simulations published. So I think this has really advanced a lot since the last report, and the model data comparison is improved. So yeah, so I think the figure is really quite nice and should really help. But of course, I'd urge anyone who has any model results of the last millennium to ideally get them on the Earth system grid by January, so we can include it in the figure. So yeah, I think that's pretty much all I want to say. But yes, it's been fine. I think the fact that it's spread over several chapters, and I think it's sometimes not been entirely clear to me what exactly is meant to go into which chapter. So I do imagine that's been a big stress for the lead authors. But yeah, I more or less have been doing what I've been told. So yeah, I think I'll leave it there.
Okay, thanks very much, Andrew. So yeah, so I guess that's an interesting point for everyone, that if you can end up being part of the process by submitting review comments to the various different order drafts. So that can be a really efficient way of getting involved in the process. And I'd also echo what Andrew said about submitting simulations to ESGF. It's not too late, or even if you haven't got the resources or time to submit them to ESGF, then you can send them to us directly, so we can see if we can include them. So thanks very much. Well, let me just check to see whether anyone else is here on the panel. I think that Alan Hayward may be around if he wants to just reflect. I'm not sure if he's here or not.
Yeah, I'm here, Dan. So yeah, thanks. So my role in IPCC was as a contributing author, taking a lead on the cross-chapter box that Dan outlined on the Pliocene at the beginning of his talk. So from my perspective and my background, that was essentially my dream job as far as IPCC was concerned, to be able to be involved in that. So I greatly enjoyed that opportunity. I think it's a nice product that is emerging from there. I think much has been said in terms of the way that it's working in the context of the new IPCC structure, with the federated profile of paleo throughout the document. And I too, Dan, as you know, was quite skeptical about that to begin with, but I think actually as I've seen it evolve more, I've become more confident in it. But I would actually highlight the thing that you and others have also highlighted, is that the communication is absolutely key. And I think one example, I'm just looking at a comment which is put in the text about what's the geological evidence for Pliocene ice sheets. So it's triggering my memory about some of the projections for the ice sheets for Pliocene that are going into the other chapters. It is extremely difficult, and I think, to me, I don't know how really, being a contributing author, to actually try to influence what's going in terms of relevant things for Pliocene in other chapters. I think I probably started off the process thinking that it would be through a negotiation and exchange that we would come to an agreement, but I think it's been more like the box has been adjusted to fit with what chapters have said elsewhere, rather than having that opportunity for a dialogue. But having said that, beyond that, I think the process has worked very well.
Great. Okay. Thanks very much, Alan. So the people who've spoken so far all have been sort of opted on as contributing authors into the process, but they're also, Pascal has also been involved as a review editor. So I just ask her to take the floor just to explain her role as well briefly for everyone.
Okay, so I make it very rapidly. So review editor as a garant for all the review comments people can put in the different chapters. I'm part of chapter 8 on that for the hydrology. And it's a role that is finally quite important because there are many, many thousands of review comments. There has been quite a lot of review comments for the paleo. So it's also important that this is taken on board, and it helps people in practice to go one step further in the analysis of the literature and the way they can convey the different messages or the messages across the different periods. So I think it's very important. The process, I think, at the moment is going on well, and I really think the paleo people are doing a great job. It's not that easy to be distributed between different chapters, I think. And it's a big challenge. And I would like to echo a little bit what Masa has said, is that and it's normal in the IPCC process, and each time that the same thing, that people are trying to invent something new, because it's very nice to see all the things coming on together in an IPCC chapter, and suddenly you realize all the science that has been done and what you could go one step further. So it's very tempting to do the new science. But people have also to go with all the literature. So there is not only PMIP 6, there is also PMIP 5, PMIP 3, all the other paper before. And the role is really to show what is new, what we understand better now for climate change, and for us with the paleoclimate, what is relevant. So it's lots of discussion going on, and that's why it's important that here people can also discuss and say what they think about the process, or what is in the chapters, or the figures, or new things that could be there. Maybe they will not, but there might be other ideas that come in.
Great. Okay, thanks very much, Pascal. So thank you for all the panel members for your words. I think we'll move on to address some of the questions, but just before we do, can I just check how long we have left for this session?
You need to stop at 10 for me, so 9 for you.
Okay. Thank you. So we've got 10 minutes to answer some questions. So I'll just go through them in order. So first, Marie-France said that we've really focused on the PMIP modeling contribution to IPCC, but what about the data side? So that's a really good question. And so the paleo working group is actually, there are many more people actually from the paleo data community than there are from the paleo modeling community. And so, for example, Kim Cobb and Daryl Kaufman have both been very involved in coordinating the paleo data side, and particularly in chapter 2, which is the observations chapter, Daryl has been very, very active in coordinating the paleo data across the whole report. So, for example, there's going to be an annex, a paleo annex to IPCC that lists all the paleo data sets that are assessed in some way. And there's a cross-chapter box that he's written that highlights all the various different time periods and what what their characteristics are. And between the modelling and the data, there's been a group of us who've met fairly regularly to discuss model data comparisons and how best to do that. So actually, I would say that in the end, mainly through the work of Kim and Daryl, that paleo data side coordination has gone really well. And I think the paleo data side, again, I didn't show any of those figures, but there's lots of very, very nice figures that are very relevant to the PMIP community across the whole report. And then Huayu says, maybe this is one for Alan. I'll pass over to Alan for this, but he asked, what's the geological evidence for ice sheet size in the Pliocene?
It's a very good question. I have posted a response to it. The basic answer to the question is there isn't really enough, but there is some. So we do have some paleo shoreline data from around the world. Obviously, dating that precisely is a key control. You can do some work to try to deconvolve the benthic isotope signal to get back to the sea level change. There is some outcrop evidence from Greenland. Again, the critical thing there is actually about dating it. I think in Antarctica, the more recent work that's come out over the last 10 years or so, I think has put us in a slightly better condition in that sense. So we've had the Andril work, which has looked at the condition of the West Antarctic ice sheet, and then more recently the IODP work, so the Wilkes margin and the Pritz Bay studies that looked at the margin of East Antarctic ice sheet. So there is some, but the answer to the question is there isn't enough. And so the estimates of the ice sheet distribution that you see in the published domain and also in the IPCC are also in some respects products from model estimates. So trying to get an estimate of the uncertainty from the models. And I think, you know, Dan showed the plot of the Greenland Pliocene ice sheet from that particular chapter of the IPCC, and I sort of see that. I recognize it as a Greenland ice sheet configuration, which is within the uncertainty of what I know in terms of the Greenland ice sheet, but it wouldn't be my personal 50th percentile choice for Greenland in the Pliocene. But that goes back to my previous comment really about trying to get input into other chapters. But so the basic answer is there is some, but we need more.
Okay, thanks very much, Alan. We have a question from Gilles as well, who says, because the summary for policymakers is based primarily on chapter summaries, isn't it more efficient to have a paleo chapter in order to be more involved in the summary for policymakers? Well, I wasn't involved in it in AR5, so it's difficult, or not directly. So it's difficult to make a like for like comparison. But from what I can tell, from talking to people who were involved in AR5, I think, well, if you look at the summary for policymakers from AR5, like I said in the presentation, you see there wasn't a huge amount that got in there. And I think we'll know the answer to your question when the summary for policymakers in AR6 comes out. But my impression is that because as a group of paleoscientists we're embedded within the chapter, it's actually more it's perhaps more easy to make that direct link between the paleo and the future and the policy relevance, because we can have a perhaps more detailed discussion with the future climate and process-based scientists about how paleo can or what paleo has to say about those different processes, and how the information from the paleo can inform future projections. Whereas when it was all the paleo in one chapter, it was a little bit more siloed and perhaps a little bit easier for chapters to ignore. But the proof will be in the pudding when it comes out. So I'll answer your question better then. We have a question from Sandy, who says it would be interesting to expand on what is the best way to quantify natural variability in the paleo record. Well, one of the approaches that's being done in chapter 1, and this has been some of the work of Kim Cobb, for example, is there's quite a bit of text. So there's quite a bit of text in there in terms of what the coral records can tell us about natural variability over recent times. But maybe Andrew could expand a little bit more on this one in terms of, for the last millennium, how we can perhaps best define natural variability in terms of providing a baseline for what is normal, if you like, when looking at more recent change.
Yeah, I mean, I think the last millennium is probably the best place to look. I mean, but clearly the primary evidence has to probably come over the long instrumental record, but obviously during that period there's a strong anthropogenic fingerprint, and it's not all that long. So I think if we want good estimates of decadal variability, then the last millennium is probably our best bet in terms of using all the multi-proxy evidence we have. I'm not quite sure what the question really alludes to here, but yes, we can certainly learn about like natural variability like volcanoes and the effect of solar installation, as well as internal variability, by really trying to understand the last millennium, which after all is mainly natural variability. Yeah, because I think which is really very important, obviously, for near-term predictions and also detection attribution of a lot of statistical analysis, which relies on good understanding of natural variability to work out what the human fingerprint is. And I guess that is to some extent what chapter 3 is. So I like to think that the last millennium will play a bit of a role on that. I don't know if that really addresses the question or not.
Yeah, that's great. That's great. Thank you. Thank you, Andrew. Then we've got a question from Massa, who says maybe one regret. It would have been good to include info on last glacial sea ice. And I think that's a really good point, actually. I think that this is somewhere where we could have done more, perhaps, as in terms of the paleo contribution. In that, I think at the moment the paleo is being used to evaluate models, and it's being used in terms of some emergent constraints on climate sensitivity, and paleo data is being used on looking at estimates of ECS. But one area where the paleo potentially has a lot to say, and it isn't being used a lot, is in terms of processes and feedbacks in the climate system. So, for example, there's a section on sea ice feedbacks, and it would be really nice in there if we could have perhaps included something on model data comparisons of sea ice during, for example, the last interglacial or the mid-Pliocene or the LGM, to be able to evaluate some of the models under conditions very different to those that they were tuned towards, if you like. So I think it's not, so I would totally agree with Massa in terms of sea ice, but also other processes. One of the things that we're trying to do at the moment is better quantify some of the non-CO2 biogeochemical feedbacks. And I think there could be more there on using the paleo to evaluate, for example, methane at the process-based modeling of methane at the LGM, for example. Dust feedbacks as well. I think we could perhaps have done more on that. So I think maybe that's sort of a lesson for next time in terms of integrating the paleo information into the sort of process, more into the process-based chapters, perhaps. And then we've got a question from Steve Sherwood. It says, have you come away from AR6 with the insights into how paleoclimate research could have greater impact on policy relevant predictions, conclusions? Well, I think that's a very important question. I think what I'd like to do is ask each of, just to finish off this session, because we're coming to the very end, is to actually ask each of the panel members to give their thoughts on that question. So if we'll start off with Chris. We'll go through in the same order that we had before. So if all the panel members could just reflect briefly on that question, we'll start off with Chris.
I'll be honest, I'm still not quite sure. I see paleo as being useful for unknown unknowns, like demonstrating things that could have happened that we weren't necessarily sure about, and then so putting model projections in a wider context. I don't think we've done enough work on thinking about precisely how we can constrain future projections to make the paleo conclusions be sufficiently policy relevant yet. So I think there's more research that needs to happen before the IPCC can draw quite some quantitative insight from it. But that's my opinion.
Okay, thanks, Chris. Massa?
Yes, I think that's a really interesting question that calls for more multi-period analysis. There's been quite only a few multi-period analyses now on how we can relate results for paleo simulation and results for future. I think only Joe presented this morning something about this, and that's really that would be really interesting to do this, and it's very important, I think, for the next report.
Okay, thank you very much, Massa. Alan?
It's a good question. Good questions are always the ones that are most difficult to answer. So yes, I agree with what Massa and Chris have said. I think the answer in this space is that we always could do with more. I suppose when I reflect on the Pliocene aspects of it, I think there has been an sort of increasing focus on understanding the kind of degree of warming and the degree of change we're sort of already signed up to in terms of the CO2 forcing that we have. And I think that kind of longer term equilibrium to current forcing, current levels of forcing, how that interfaces perhaps with the 1.5 degree world debate. I think there has been some progress there, but I think there's still an awful lot to do.
Okay, thanks, Alan. And Andrew?
I'm not sure I can comment too much about the wider paleo debate, because I've really only been involved in the last millennium. As far as the last millennium goes, I think some efforts have been made to try and understand variability and to try and try and work out whether trying to put the present and the future into context. And I think there has been a lot of emphasis trying to understand the effect of volcanic eruptions. So I think all of that will be potentially very useful for the future. I don't know whether there's been enough, and I guess you can always do more. I think my feeling is that some effort has been is going in the right direction there. But yeah, I'm not sure I could really comment much more than that.
Great, thanks, Andrew. And Pascal?
Yes, I think things are going on well, but we could do better. The problem we always have is that it's always a rush with the IPCC report for people involved there. And we really need to take time within the community to have more workshop on it, more discussion, and more integrated work on key questions between us. And I really would like to see this in the future, and also as part of PMIP when looking at the different results, so that we have a particular thinking and we have the time to deliver our messages and to see how it connects with other communities.
Okay, thank you. And just to answer very quickly the question myself, one thing that I've learned in some ways is that in some ways the simplest things are sometimes the most powerful. And certainly that I've found that one of the most useful constraints that the paleo can give in terms of future climate change is simply how good a job do the models do of simulating global mean temperature change for these key time periods. Now, in order for that to be useful, we need the best possible constraints that we can have on what global mean temperature actually was at these time periods. So I would think if this community could do one thing, it would be to really work very closely with the data community, working on the LGM, the mid-Pliocene, deeper time periods, those that have a significant global mean temperature change, to really get the best possible estimates, the best understanding of the uncertainty, just in a really simple metric like global mean temperature change, so that we can have a powerful constraint on the paleo warming in the models, and therefore an indirect constraint on their future warming. So I think in some ways, simplest is the most powerful. I realize that we are running a little bit over time. Now we've got lots of really interesting questions still to answer in the chat, but what I suggest that we do is we answer those in the chat as the next session is due to start now. But I would finally just like to give an opportunity to the local attendees in China to see if they have any questions for the panel before we wrap up this IPCC session.
May I add something? Maybe we have a question from the room in China, but you also have the Padlet, so please use the Padlet. I started to put some questions there. You can answer them, enter the discussion, and you can also add new posts so that you have another line of discussion with people. It's very useful. We can keep everything on the web with this Padlet, so it could be nice you use them and we see if it works. And we will try to keep the track, I hope, of the chat box.
Hey,
hello. Can you hear me?
Yes, I can just about hear you. If you speak close to the microphone, we can hear well.
Maybe from here?
Yes, that's good.
Okay, great. So I think from this session, I'm not quite sure whether we have questions on this IPCC session from the local. Do you have any questions? I mean, the local participants? I think at this moment we do not have any further questions regarding the IPCC session.
Okay, thank you. So I think we'll wrap it up there. Thank you for your questions. And like I said, those that we haven't been able to answer yet, we will post some answers in the chat as we go along. So thank you very much.
Okay, thank you, Dan, for this. And I hope people enjoyed this session. And we can continue for all the week the discussions. And you can bring your ideas in those discussions and also bring your ideas to the IPCC lead author. We know them and you have them in the IPCC reports online. I think we have a 10-minute break now before we go to the next session with model data. Is that right? So I let the floor to the Chinese group.
Pascal, are we not going to take any questions on the presentations of the PMIP papers, which we didn't have?
It was a little bit, yes, but we have to move on with the, so for the question with the PMIP paper, the same. You have the videos available on the Padlet, and you have an image, and you can post your questions for each of these presentations, and people will answer later on, right? And I suppose some of the questions can come into during the discussion with model data, because I suppose lots of questions are for model data comparisons too, for the next session. Is that right?
Yeah. Sandy, so probably we can just have these questions for the PADIO papers in the last session. I mean, because at the last we have discussion, we can freely discuss all these questions regarding the PMIP papers. So now we'll go back in 10 minutes later, right? For next.
Good.
Yeah.
So we have a 10-minute breaks now, and when we reconvene in 10 minutes.
Okay.
Okay. That's what is on the agenda. So we need to break a little bit.
Yeah. Okay. See you 10 minutes later.
Yeah. See you in 10 minutes. We try to be all on time, right?
Yes.
Good.
So was the face mask to do with the French flag, Pascal, or?
Hey, Sandy. Shall we play the video or just you give the live presentation for your talk?
Play the video.
Okay.
Play the video. You've got it. Yeah?
Yeah, we can play. Yeah.
I did send you a message about it, but maybe you didn't get it.
Right.
I want to provide an update on model evaluation in PMIP4, and I'll be using some examples from ongoing work benchmarking the LGM simulations. The main differences between our benchmarking activities in this round compared to PMIP3 are the use of multiple quantitative data sets to capture data uncertainty, the use of more extensive environmental data sets directly whenever possible, comparison to explicit null models that distinguish the source of potential mismatches, and more extensive use of forward modeling. In Massa's preliminary analysis of the LGM simulations, we made use of multiple data sets to look at land-ocean contrast, shown on the left, capitalizing on the new Claytor et al. Dataset for land variables and the new Turney et al. Dataset for the ocean. The use of multiple data sets allows us to consider uncertainties in the data. On the right, I'm showing a comparison of the Bartline and the Claytor data sets for 3 climate variables. In places where the 2 data sets overlap, shown in the orange and the dark blue here, they are very similar to one another. But the Claytor data set is more extensive and shows somewhat cooler conditions at high northern latitudes and warmer conditions in the extratropics. We will also use data sets other than quantitative reconstructions, and here I want to make a plug for using speleothem isotopes for benchmarking. So please see the presentations by Sarah and Roberta for more information on this. Last time round, we made comparisons of individual climate variables against model predictions, and we will continue with this. I'm showing here zonal comparisons of precipitation and winter and summer temperature against the PMIP4 models using both Bartline and Claytor. But we plan to move towards more process-based evaluation by adopting a scheme used by the vegetation and fire modelling communities, where we compare the simulations to 2 explicit null models created by randomizing the observational data set and using the mean value of the observations. We make comparisons in 3 steps, where steps 2 and 3 deal with mismatches due to bias in the simulated mean climate and to biases in the simulated variance. Here I'm showing those 3-step comparisons for the Bartline et al. Dataset globally for 5 different variables. In order to interpret these plots, you need to know that dark brown means model is worse than the random null model, yellow means worse than the mean but better than the random model, light green means better than the mean, and dark green means 25% better than the mean. In this comparison, you can trace an improvement due to the removal of biases in the mean climate. In other words, whether the model is too cold or too warm compared to the observations, but a degradation as you move towards considering variability, suggesting that the spatial differences in the model are too muted. We can also make these comparisons for different regions, and here I'm showing the global comparison for Bartline and the northern extratropic comparison for Bartline on the top. And we can also make them for different data sets. So here comparing the northern extratropics from Bartline et al. And the northern extratropics from Claytor et al. Finally, we plan to make more use of forward modelling in the evaluations. The example here is using simulated vegetation compared to vegetation reconstructions from the Biome 6000 dataset. And we're using a metric, delta V, that allows the degree of match to be assessed based on the communality of both physical form and plant traits, rather than asking the question, have we got the right biome or not? Delta V allows an assessment of the quality of the simulations, and here we're looking at the PMIP4 models in bold versus some of the PMIP3 models. What you can see from these scores is that there's no real difference between the ensemble of PMIP3 and PMIP4. However, the tropics are marginally better than the northern extratropics, and Europe, though not necessarily Western Europe, is simulated better than the northern extratropics as a whole. So for more news, please watch this space, or better still, contact the data working group and volunteer to become part of these activities. Thank you.
So I think now it's a question for the talk. So is anyone have questions on this talk on data model comparison and to know the evaluating the reliability of the data to qualify the model output? So do you have anything to add on to your talk to explain something? Because I think some font in your figures is quite smart to really see quite clear the meanings of figures.
So I don't have anything about the talk, but I do want to say that I think there are some issues in data model comparisons that we should all be thinking about, and I hope we can have the discussion of this during the week. So one of them is about the timescales of registration of different data sets, which are not always either annual or decadal or centennial. We need to separate these out. I think we need to have an emphasis on looking at the representativeness of observations, and that's particularly the case as we move back through time and we don't have good spatial coverage, which I think is a point that Alan raised earlier. And I also think we need to be thinking from the data's perspective about the need for new chronologies, because now we have IntCal 2020 out, which means that much of the data that we've been using in PMIP up till now will need to be recalibrated and age models redone. And then finally, I think we need to discuss a little bit more about what we mean about the pre-industrial, because this has obviously come up in the context of the IPCC, but we traditionally take 1850, and there has been a substantial change, and many of our records actually don't relate to the climate of 1850, they relate to the modern day. So these are all issues I think we must discuss sometime during this week.
Yes. So I mean, okay. So regarding your talk, I think somehow you always show example based on the terrestrial records. Is that possible to really extend your techniques to the marine records and to really think about the way how to calibrate the core top data with observations, right?
So the techniques I'm showing there could be used with marine data as well as terrestrial data, and they can also be used with other kinds of terrestrial data. So as long as we have something quantitative, we can set up these null models, which give us a way of then evaluating what is underlying the mismatch, which I think is the key step forward here. I think up until now we've been looking at, oh, the models don't do it, or the models do it, or they're within the ballpark. But we really need to go now into greater depths and find out what biases are influencing these data model comparisons. So I'm showing the terrestrial stuff because that's what we started working with. But in this benchmarking paper that we're developing at the moment, we will be looking at marine and several different kinds of data.
Yeah, that's great. Is there any questions from the online audience? Okay. Oscar, you have a question.
I think Pascal has a question, if that's what the exclamation mark means.
Yeah.
Yes, I have a question, because you mentioned the data modeling, or we call that proxy modeling, but you don't like the word proxy.
I don't.
So on the Padley, because there was this question from different working group leader in PMIP, is how far we should go in PMIP with this proxy system modeling, and how do you see this? How do you see the discussion during the week on this topic? Because there are lots of different aspects in there. Lots of different types of modeling. We also have this model now with dynamical vegetation a little bit more. We can have isotopes and so on, but it's all different steps. So what could be the way to go forward?
I think we do need to push process modeling, because we need to understand what the data are actually showing us. Now, insofar as some of those process models are already encapsulated within the climate models, so in terms of isotopes and in terms of dynamic vegetation, I think we've got a lot of work we can do there quite easily, because it's not a question of having to develop an offline model to look at them. So I think we should be pushing that. But I do think that for other kinds of records, we need to be developing forward models that tell us something about the processes involved. Because otherwise you assume that proxy X means something to do with the climate, but there are many other processes that are not being taken into account, and we do need to look at those. And of course, I'm thinking most of all of CO2 and its impact on the biosphere, which is not only through the climate change.
So since there is no other question coming in, I have a connected one. When we run dynamical vegetation simulations, in most our simulation, then we have only the natural vegetation, except when people keep land use in there. So this is sometimes unclear what has been really done. But when you do that with only natural vegetation, then you have the problem that you cannot compare your model result for present day with observations because you do not have the land use. And then in that case, that's why I always say that the only way to go is then to compare the vegetation you simulate for the paleoclimate when there is no anthropogenic effects on it. So do you have ideas, or do you see some discussion we should have during the week to go on with this type of questions?
So I think there are two things. I mean, one thing there are now maps made by machine learning of potential natural vegetation in the present day. And I think it would be interesting to make comparisons of our model simulations with those. And then the second thing is, and I'm not sure whether Marie-Jo is online or not yet, but the Land Cover 6K group are developing products that will have the anthropogenic land use over the last 8,000 to 10,000 years incorporated in them, so that we can then do exactly the same as is being done for the last millennium for transient simulations of the Holocene. Because remember, the last millennium simulations do have anthropogenic land use changes in them, which we can use to try and pick out how big an impact they have on the climate. And if we could do that for the Holocene, I think that would also be useful. And I think Marie-Jo has got a presentation or a poster here which will show people about the Land Cover 6K work to date. Okay, Sun Wei has got a question up here, so I will just quickly answer that. I'm sorry I skipped over that very fast. One of the things that we are trying to do with introducing these null models is to set up a comparison that says, if we didn't have the paleo data in the form it is, how far out would we be in our climate model simulations? So the two null models we're using here, which are the sorts of null models that have been adopted both in PMIP and in the ILAM intercomparison for vegetation, are that you basically randomize your observations and then you compare the model to the random set of observations, and then you take the mean value of the observations, and that's your second null model. So the mean value, an average value across the observations, which you can then compare your simulation to. Now, in an ideal world, obviously, you would like your model to be better than the mean value of the observations, and certainly much better than the random model. But as you can see from the plots, if you go back and have a look at the plots, because it's all been recorded, in fact, in many cases, we're only marginally better than the average value of the observations at the LGM.
There's another question from Alan Howard, I think.
The short answer to that is no, not yet. There are massive age models. So Alan's asking about progress on the Pliocene terrestrial work, where we are trying to use up-to-date statistical techniques to reconstruct temperature changes during the Pliocene. But one of the major problems there is that the dating of those records is very, very poor.
Is anyone have questions about Sandy's data model session? Pascal.
You are muted, Pascal.
Sorry, I'm muted. So I think that an important point would be for me also to hear from people's question, what we should discuss during this week for the model data, because everybody is concerned with model data comparisons, for error bars, for uncertainties, for the way we assess the realism of the models, having more, for example, on the ocean, it was written here. So is there different views in the audience where people would like to ask questions or to tell what they would like to discuss this week?
There was quite a lot of data model comparison in the talks we had earlier. And I do wonder if anybody has any specific questions for the presenters of the PMIP papers, Chris and Massa and Alan and so on. So it might be an opportunity for people to raise their hand and ask questions if they do.
I think if we do not have further questions about data model comparison session, we can go back to the discussion about the PMIP papers. Just check whether there is questions on the chat window.
So maybe I just tell also that I put starting points for discussions for model data on the Padlet. So it could be nice that people go there too and continue the discussion so that we look at that during the week and we make progress on it.
Yes. I think we can just think about planning an overview paper on that. So any comments from you, Dan? Or questions?
Yeah, it's just a question to everyone, really, to the community. I think there could be some really interesting results from looking across multiple time periods, which is something we don't do very often. Looking at all, I don't think we've ever had a paper that looks across all the PMIP time periods, and to ask questions like, if a model does well at one time period, does it also do well across multiple other time periods? We've done it a little bit for the LGM and mid-Holocene together, but never, as far as I'm aware, brought together all these time periods, and wondered whether that's something that as a community we should be aiming to do. Or if anyone would like to lead it.
Well, I'll step in, if I may. I'm not volunteering to lead a paper, but I do think one of the problems is actually it requires quite a lot of data analysis to do something like that. It's hard enough getting a model, collecting all the data for just the one model simulation, say the mid-Holocene or the last interglacial. But I do think some of the stuff you were talking about, with Dan was mentioning about things like ESM Valtool and some of the more automated things, can start collecting some of these data together to make things a bit more easy. From the modeling side, it's quite easy. And so for the paper that was on, that Joe mentioned about ENSO, the model data is the same all the time, but the proxies are not. And how the proxies differ between the different time periods and how you cope with the different levels of information can provide some real challenges. So multi-period model analyses are doable, and I can see that some will happen, although I don't necessarily know what. And hopefully at the end of this meeting we will have some plans for some. But from the data side, then it does become more challenging, especially as the communities are sometimes different. Sort of the Pliocene data community is different than the last millennium data community, and so I think it does become hard, but it's a problem that is eminently solvable with enough willpower.
Yeah, I don't think it'll be easy, but I think it could be a really nice outcome of PMIP4 if we were able to do that. But like I said in the chat, it's also confounded by the fact that I don't know if there are any models that have actually simulated all the PMIP time periods anyway. So
I don't believe there are. There are people with just one missing, say, but yeah. So Sandy, do you want to hop in? You've made a comment about in the chat, and maybe the audience would like to hear your comment about from the proxy side.
I don't have a proxy side. What I wanted to say is that before we do the sort of multi-period analyses, I think we really have to pay some attention to how much data you need to be representative. So Dan was asking for mean annual temperature. If we have a lot of data from the northern extratropics and nothing in the tropics, how representative is that? And then as we go back in time, we automatically start losing data. And so I think, we need to know, are 37 sites enough to represent the mean climate? So I think there's actually, before we start doing some sort of synthesis paper, I think there's some actual research we need to do to just ask, when is enough, basically?
Oh yes, I completely agree with Sandy Harris' comments. If we look at the data, we can see most of the previous results are qualitative. They are not so much quantitative. And in the other side, some proxies just indicate the different timing, different period or season. So first, I still think we should review the previous data and to understand what and where we should collect more useful data to compare with the modeling results. Thank you.
Sandy, so regarding the data, so as a modeler, I think somehow it's really hard for us to really evaluate the reliability of the data we can use for data model comparison. Is there any kind of standard criteria for us, or maybe for beginners to really use the data for the data model comparison? Because I think if we use the null hypothesis, I think this quite a kind of well trained. But I mean, if there's no any background about data, so how can we choose the right data to compare? Is there any rules or any standard to do that?
Well, we've tried to make data available through PMIP that we think is reliable and useful. I think the other side of it is that we just have to work together with the people who are producing the data so that we understand what those observations really mean. And I wanted to go back to the previous comment, which is I really echo the fact that we really should avoid putting multiple different types of records together on the assumption that they're all recording the same element of climate, either seasonally or time frame, you know, long time frame versus short time frame. So I think that it's important that if you're going to use data for data model comparisons, that we use data sets that have documented exactly what they think the data is showing, and that we treat them all with some degree of skepticism. I think Massa has a question.
Yep. Oh, hello. So yes, maybe one other way to start with working on multi-periods would be to work on the model results and see where they are, where they diverge, where they converge, and then use this as a guidance of regions where we can compare to, or where it would be more useful to compare with data. And that could also lead to analysis of the processes at work and compare between the different periods. So I don't see one overview paper. I think there's several overview papers. It's impossible to put everything in one. And maybe we should see who would be interested in going for analysis on the multiple periods. I think there's still a few simulations missing, looking at the poster by Jean-Yves. And so it will be a difficult task. Already for the LGM, we don't have so many simulations because they are hard to run. And so it would be a challenge, but I think it would be interesting to at least look at the forcings and feedbacks within the models and use the available data to check if this is working or not. And I fully agree with the question on representativeness of the data. It's something we have to think collectively. I think it's data also from a particular site where they could be collected, and it's difficult. And I think the models don't have as much variability as the data, so it's really difficult to tackle this question. And it would be good to think about it.
Massa, you mentioned feedbacks, and I really think that the data community should be thinking about how we quantify feedbacks, because as we start building in processes in the models like vegetation or dust, or, you know, not isotopes because they're traces, but vegetation and dust, the question is, are the feedbacks due to vegetation and dust actually of the right magnitude in the model world? And I think the only way we're going to get to that is by looking at trying to quantify those feedbacks from a data perspective. So I think that's something really important to do. And I hope somebody else wants to do it as well. Don't all shout at once.
Just a quick follow-up about this LGM simulations, because I mean, in the PMIP4 model, I think, so all the models show quite consistent, I mean, strengths of the AMOC. I mean, this can, I mean, in this point, I mean, whether we should trust the model more than data, or we should still stick to the data to say, okay, the AMOC should be shallower, and the responses could be, I mean, the AMOC, I mean, the model could be a little bit biased towards an unrealistic state. So I mean, how to judge at which kind of period we should trust the data more or trust the model more? Is that possible to do that, or?
I think there's on this side, there's the interesting approach of assimilating data. We have to be, so there's a few papers like the one by Jess, maybe she will hear us when she gets awake, who try to assimilate data as much as possible and see how consistent it is with other data. So maybe that's a way, and we have to consider it. And I think if you look back on my talk, this is the CESM 1.2 results, which are very cold. And so there's a lot of things we can do by trying to assimilate one part of the data, not all, and see how consistent it gets on the data that we don't use for assimilation. It's a lot of work. So also it would be interesting to see if other people have developed such techniques. But that could be a way to go for the AMOC comparison that you mentioned.
Regarding the policy, the relevance to the policy, I think people are much more focused on or interested in the future climate. I want to learn something from paleoclimate. And so far in the PMIP4, we focused on the climatology or equilibrium simulation in the past. But in the future, regarding the very fast CO2 emission, so in the future, our climate is not in an equilibrium state. So how can we link this paleoclimate equilibrium simulation to future? Is there any thought on that? Or maybe we have a solution, probably.
I think there's many links that could be made. There's the big work on equilibrium climate sensitivity that has been published now, and that shows that even the equilibrium simulations are useful, and data are useful to constrain climate sensitivity. I think Steve, maybe Steve is still around and he can speak more about this. He will speak more about this in the next few days. But I think that one of the potentials for paleoclimatist is that because when we consider data, it's really about paleoclimate change impacts. The impact of climate changes on vegetation or dust or other things, and that can be very powerful into talking to policymakers. Maybe I'm not so clear, but I think it's really, we are checking, we know about paleoclimate changes through their impacts, and that makes them very relevant for future, to assess our abilities to evaluate future impacts. And maybe we haven't advertised this very much in this way.
Okay. Yeah, thank you, Martha.
So I wanted to follow up on a bit on the issue of feedback. So Sandy mentioned vegetation and dust, and I think in the PMIP papers we actually foresaw the possibilities of some sensitivity tests on these two aspects, for instance, as well as on the ice sheet. And so it would be also useful to, at some point, maybe collect the intentions of groups to perform, if they have performed some of these tests. So we could also think of seeing what the model sensitivity somehow is to these parameters. And that would eventually lead to the possibility of also comparing with the data, as Sandy mentioned.
Yeah,
Sam, can I ask you about doing it just from the data point of view? So in terms of the dust records that we have, for example, how many of them go across the Dansgaard-Oeschges?
Well, we don't have, so I think what we have more data clearly for the time slices still, right? So mid-Holocene and LGM, as it was the case. We do have some. I'm still working on extending the database with the time resolution. I don't have a sense to give a clear number, but we do have, we will have for some areas. So the issue of the coverage is still there, and with different resolution, clearly. Yeah, I don't know if it will come with the desired or optimal resolution for many places, but I think it would still be worth trying. I don't know. Can reassess this maybe 1 year from now, I guess. I don't know. Something like this.
Is there any questions from the online audience? So just a moment.
So
we have.
I have one. Is that we discussed a lot in the previous question somehow climate sensitivity. So it's mainly we are looking for temperature and different records for feedbacks. I think there's a lot to do also for the hydrological cycle and the water cycle. It's even more difficult, but the same, I would like to hear people about that. And it's difficult because it's not only the mean state we are looking at too. We want to know also when the different records reflect droughts or other big events, and how we can connect all those things together. So if there are some ideas about it in the room. And I also will send an email on the chat saying, hey, I would like to hear more about the ocean people, so that how they're progressing and what we can do with them.
So I have a question from the local audience. So, so there's a question about this data model comparison. If we consider there is uncertainties or large uncertainties in the data, if the data can represent different seasons, how well we can use that data to compare with the model if this kind of information is not clear. So do you have, is there any kind of synthesis paper or review paper discuss about this seasonality biased data or for data model comparison?
Well, I think all of the papers discuss a little bit about the seasonality bias, and that's one of the reasons why we've been moving away from measures like mean annual temperature to looking at seasonally explicit reconstructions. So the pollen-based reconstructions are seasonally explicit. In the marine world, there's been a lot of work on looking at the fact that the SSTs are, they do reflect the season of the blooms rather than being a mean annual temperature. So usually more biased towards the summer. And in the isotope world, then people do know and have written about the fact that the isotopes, for example, in the monsoon regions, are biased towards the summer, even if you're taking it as an annual season, annual record. So there's quite a lot of work on that, and I think most of the reliable data sets have discussed both the uncertainty in reconstructions and the uncertainty in terms of what they mean in terms of seasonality.
I just have a quick follow-up about this data uncertainty, because if in the climate state we have a very quick and short interannual or decadal variability, for example, in the North Atlantic, and is that possible that some species would like to record a warm period, and then if we reconstruct the paleo-ocean properties, we only see the warm signal. But actually, I mean, if you look at the climatology mean, probably the temperature is quite colder. So if you look at, for example, if you look at the histogram of the SST, if there's a large variability, so there's probably two peaks, one is -1, another one is 2 or 3 degrees Celsius. And some species would like to record the warm period. And do we have any kind of review paper or kind of plan to really do some kind of work to report this species to help us to do the model data comparison?
So I think in general from the ocean records, they are going to be biased towards the warm end. I think you have to bear in mind also that both on the land and in the ocean, we're generally dealing with mixed signals over 10, 50 years, sometimes 100 years. And so you're getting kind of a long-term signal. I think at one point within PMIP, we discussed the idea of coming up with a sort of a review paper on PMIP data, and it got sidelined for various reasons, but maybe this is something we need to do for the community.
Okay, thank you, Sandy.
I think another point with the ocean data is that it doesn't always sample the surface. So that is something that we have started investigating, and maybe one day we can publish the paper, which has been standing as low priority for quite a long time. But this is a very important thing, and considering that some ocean proxies could actually record subsurface, would bring a lot more information on the ocean circulation at the surface. For example, the ocean thermocline in the Pacific, in tropical Pacific. So there's lots of potential on this. There's only some work to do and to find the time to do this. But I think that's why the assimilation of ocean data has a lot of potential, because we can try all these hypotheses, and it makes the model data comparison more difficult, but at least we know more about the processes that make the data different.
Yep, nice. Just to look like this, some messages from the chat window. Projections. Sandy, do you have any comments on the comments from the chat window regarding the?
Okay, so Andre Paul is online, so maybe Andre wants to talk about the ocean data a little bit more. Yes, it's right, Andre, the bias does depend on the regions, but the point is that there is bias both in terms of season and in terms of depth. Did you want to say something? Represent the oceans.
Andrew.
Yeah, hello everybody. It's not easy for me to do that off my head, to bring up the reviews or articles, but it's not the case that there are not review articles on ocean data or ocean model data comparison. So we can try during this week to give some further references and some ideas. So it occurred to me that 4 years ago in Stockholm, we had pretty much the same discussion, and 8 years ago, we had pretty much the same discussion. So we somehow need a way to make sure that we make progress and also help people joining the field to not start from scratch. That was my feeling when I listened to the discussion. Thank you.
Okay, I think time is up. So I think we should close today's session now. And does anyone have any further questions? If not, we will close today's session.
Okay, so maybe I just have a last comment. So thanks a lot for the session. I really encourage you to go to the Padlet and to go to the discussion. There are a few points that are already listed there. You can continue the discussion on this point, and feel free to add discussion there so that we can continue to interact during the week, and we can wrap up new ideas at the end of the meeting. So it would be nice. Thank you.
Okay, thank you, Pascal. So thank you, everyone. Thank you for attending to the online PMIP 2020 conference for 26 October. So we will close the session today. And tomorrow, I think it will start. Okay, Just a moment, we have another question from the local audience.
Hello. For tomorrow's section, the repeated overview section, I want to know who will join in the section. In particular, for the talks in today, I know Pascal will be there. How about Masa? Masa, can you hear me?
Yes.
Will you join in the repeated overview section?
I will try.
Maybe
I
it's...
will try to switch to Chinese time.
I haven't done that. How about Chris? Chris, will you be there?
No, I'm afraid not.
Okay.
I'm going to be in bed.
Alan, how about you?
Possibly, I'll try my best.
Okay, I see. Dan, I know you will be there, right? You will talk about IPCC again, discuss with.
Well, I think I'll be there available to answer questions, as will Jess, but we're assuming that people will have watched the video already.
Yeah. How about Sandy? You are muted.
Oh. No, I'm afraid I won't be there, but
okay.
Pat Bartline will be there, and he'll be able to take questions on the data working group.
Then I will talk with Betty to let her know who will be there, okay? And we have an announcement here. So we need to ask everybody to open your camera. We need to take a shot, screenshot. Everybody.
Yeah, okay, thank you, everyone. Okay, thank you, everyone. So we have to close the session today. See you tomorrow. See you.